in this session, I'm going to talk about how to maximize cost efficiency of generative AI workloads, and basically how to keep it all under control and make sure that it brings you value, just not just hit the air. My name is Yuri Prihodko, and I'm Principal Technical Account Manager at AWS. I'm also leading several FinOps-related streams at AWS, like Cloud Intelligence Dashboards project and some others as well. So to start, let me show you some numbers. In the State of FinOps report for 2026 from FinOps Foundation, it's basically a yearly report which concluded by FinOps Foundation, an organization under Linux Foundation. FinOps for AI is reported as the top looking forward priority for the next 12 months across all the practitioners who participated in the survey. It actually took up 6 places compared to 2025 report. So FinOps for AI and keeping AI costs under control is the top of minds of community at the moment. So it's not something niche, and what we see is with accelerated growth of AI spend, AI-related spend, FinOps for AI, need for FinOps for AI becomes also accelerated. So let's take a quick look on AWS AI portfolio of services and applications. I like to split them into several layers. The applications and agents layer, which basically includes services like Kiro, Amazon Quick, Amazon Connect, like general purpose agentic AI services to improve individual productivity and efficiency. Then there are frontier agents, which basically purpose-built domain-specific agents with low effort setup and enablement, like DevOps agent, security agent. We just launched in preview FinOps agent as well. Then there are services which allow you to actually build your own and run your own agents and AI-powered applications. And from those services, of course, the main one is Amazon Bedrock. And we also have infrastructure layer of services, such as Amazon SageMaker, which allows you to train your own models, run your own customized inference, expose your models through inference endpoints, and build some things like vector search databases and more. And of course, AI-based compute powered by AWS Trainium or GPU-backed instances. In this session, we are going to talk about Amazon Bedrock and cost efficiency for workloads on Amazon Bedrock, because that's a service which actually most of the customers using to build and power their AI applications and agents. Amazon Bedrock is a fully managed service which offers a choice of high-performing foundational models from leading AI companies, along with a broad set of capabilities that you need to build Gen AI applications. With Bedrock's capabilities, you can easily experiment with a variety of top foundational models, use different models for your use cases, and customize them with your data. You can also create managed agents that execute the complex business tasks. And since Amazon Bedrock is serverless, you don't have to manage any infrastructure, and you can securely integrate and develop generative AI capabilities into your applications using AWS services you're already familiar with. And the fundamental billing unit in Amazon Bedrock is a token. And token is a fundamental unit of text which basically used by generative AI models. You probably heard and know about this. So for the sake of our session, what is important is to know that first is in Bedrock, you build by input tokens. So basically the input text which you provide to the model and output tokens, right? And also what is important also to know that AI models do not operate on the text. They convert the text to the tokens and then operate on the tokens. So basically the process of conversion of text to tokens is called tokenization. And tokenization is model specific. So if you provide the same text to 2 different models, you will get 2 different amount of input tokens, which is sometimes quite important also for billing. So when you change the models, you might end up with difference, not just in outputs and quality of outputs, but also difference in amount of input tokens and which you built on. Let's talk, and before we start even running any workloads on Bedrock, the first and fundamental choice which we need to make is to select a model which we want to use. And on Bedrock, you have a wide variety of choices of the models from different leading AI companies like Anthropic, OpenAI, Meta, Amazon models as well. So basically, it's pretty much a fundamental choice which you need to make, and we provide you very wide variety of selection here. However, choosing the model is one of the most important steps in your workload, AI workloads. So we should consider selecting a model very carefully. And let's take a look what considerations we need to bear in mind when we select a model. First is model modality. We should answer a question. Does the model that we select can handle text, images, audio, or video to match our input and output needs? Basically, if we don't have any requirements for images processing or images as output, we can choose the models which actually don't have these capabilities, and usually they will have a lower cost. Then context window. Basically, how much input can model process at once? It's very critical for use cases when you have some long and large documents, or you have lots of context processing for agentic workloads as well. Basically, how much context you can send in one API request for model to reason about. Of course, the next selection consideration is cost, right? Because more capable models usually cost more expensive. The models who can process larger context windows, they are more expensive. So cost is a very, very big and important decision driving consideration. Then latency, it's time to first token. Basically, again, the more capable models in this case will have higher latency, right? Less capable models can answer faster, which models, for example, which don't have reasoning capabilities, they can answer faster. So you can have a higher latency. So you need to think about balancing the cost, model capabilities, latencies, and one more thing, which also very important to bear in mind, is regional availability. In Bedrock, not every single model available in every single region. We will talk about some different approaches, how you can kind of spread your availability or increase regional availability. However, regional availability is also very important consideration to check if the models that you want to use are available in the regions where you want to use them. And the last but not least is service quotas. In Bedrock, pretty much as many other AWS services, there are service quotas or service limits. And service quotas in Bedrock are usually defined per model and defined in requests per minute and tokens per minute. So basically, to those metrics, define your service limits and define your total throughput. So for each model, you can find service quotas in our documentation, and you can check what the limits are for on-demand inference for your model. For many service limits, you also can request to extend them. However, with on-demand inference, which we'll cover a bit later, you will basically have some ceiling which you can reach. So service quotas per model is also important decision consideration metric or part, right? So just to illustrate how model selection drives the cost, I want to show you a simple task which, for example, I want to run. Like, I need to process 20 million tokens through a Bedrock foundational models, and I expect to get like 1 million tokens as output. So if I use Haiku 4.5, my total cost for this would be $25. If I use Opus 4.6 model with reasoning capabilities, it will cost me $125, 5-time difference. So the model selection is very important and very key cost driver here. So choose models wisely. Pretty much like, if I can compare to selecting like EC2 instance for traditional workloads, we have wide variety of instance types, wide variety of instance sizes. So selecting the right instance is quite important. You can easily over-provision. The same with models. It's very easy to over-provision and maybe use more capable models than you need. So think wisely about model selection. Now, once you selected a model, you can start using it with Bedrock API because basically you interact with Bedrock through APIs. And to use the model which you selected, you just specify the model name as a model ID in API call. And I will be using example of Bedrock Converse API. which is widely used at the moment to, for AI applications. And the same applies to invoke model API, or absolutely the same applies to Strands SDK if you're using them as well. However, when you specify a model ID, you can either provide your model ID, like in this case, and in Bedrock will run it in region, in the same region where you basically make API call. It's called so in region inference. It means that the data will never leave your current region. However, the throughput and the service quotas and limits will be also bound only to that region capacity. And not many models actually support that. It's very more common to actually help to spread capacity, provide you like higher access to larger amount of capacity. We have a cross-region inference profiles. And here you can choose two options, either geo cross-region inference profile, and in this case, you create an inference profile. It's very simple configuration in Bedrock. And in model ID, instead of just model name, you specify a cross-region inference profile. So very simple change, right, in your API requests. In case of geo cross-region inference, you select a geographical boundary like US, EU, or APAC, and Bedrock will route your requests and run inference in one of the commercial regions from that geographical boundary, right? And you can see which geographical boundary is selected by prefix in inference profile. So basically, you, of course, can get a higher throughput because your requests are distributed across multiple regions. So that's the most common scenario at the moment. And if you have some data residency requirements, like to run your workloads in European Union regions, you can choose a respective region, and you kind of have a promise that the data will be run only within that geographical boundary, like in EU-based regions. However, there is also available a global cross-region inference, and it has prefix global. So again, you can just go and create in Bedrock global cross-region inference profile and specify it in model ID for your API calls. And in this case, Bedrock will route your request to any commercial AWS regions worldwide. So basically, if you don't have any data residency requirements in your applications, or maybe you're running development environments which don't have any production data or have some synthetic data, so you can run global cross-region inference, because again, you may have get higher service quotas for on-demand inference, but also for FinOps related and cost efficiency related topics. What is very important here is that it provides 10% cheaper cost than geo or in-region inference. So it's very easy way how you can save about 10% of costs by just running your workloads with global cross-region inference. All right, so we selected a model now. Now let's talk about what capacity options and pricing options available in Bedrock, because that's the next thing which we need to specify in our API calls, and that's the next things which we need to choose. In Bedrock, there are several capacity options available. One, like the default one and standard one, is on demand. It's very simple. Basically, you pay for what you use for the tokens and our input-output tokens, which you consume with your API calls. And when you run with on-demand capacity option, your workloads, basically think about them as when you run API, when you make an API call, your inference requests is put into internal queue in Bedrock, and this queue has some prioritization. And you can choose between three options for priority of your request. You can, standard priority is basically default tier. You get like consistent performance for on-demand pricing. You don't need to have any commitment with any of them, but in general, like standard, kind of think of it as it plays somewhere in the middle of the queue. There is also a flex, which provides you discounted pricing, so you can get a lower price. And however, the latency will be higher because your request will be kind of put in this at the end of this shared queue. So again, it may be a good use case for things like, again, development environment, or some use cases like if you have different tiers of users, because you'd specify the service tier, again, is just a parameter of API calls. So even within one application, you can have different service tiers. Like for free tier users, you can use Flex, maybe higher latency, but lower cost. For premium users, you can actually use something like priority tier. And priority tier, basically, again, it's similar to Flex, but on opposite side, it puts your request kind of on the top of the queue. It provides you lower latency, sorry. However, the price is also a bit higher compared to standard, right? So you have three options for on-demand, and you can control them with just service tier property. Then if you want to go beyond the on-demand service quotas and you want to get more requests per minutes and tokens per minutes, which you get with on-demand, or you want to have you don't want to have this shared queue and you want to guarantee some dedicated capacity for you, you can use reserved service tier. So basically, with reserved service tier, you commit to 1 or 3 months for some particular amounts of requests per minute and tokens per minute. And then regardless if you are using them or not, you will be paying for them. Think of it as like reserved instances for EC2. However, you will have way higher latency, right? Sorry, way lower latency, and basically way higher throughput. So you can achieve much higher throughput compared to on-demand. So that's the way how you can scale beyond the on-demand service quotas. One more important thing that reserved service tier, it doesn't provide any discounts. So it's more like performance and throughput construct and the scaling construct rather than a pricing construct. So don't confuse it with again, EC2 reserved instances or databases reserved instances, which provide some discounts. Here it's more the way how you can guarantee capacity and how you can guarantee that you will have persistent throughput among the different requests. And once you created reserved service tier, you provisioned it, you can use then in your API calls service tier reserved, and those API calls will be run against this reservation, right? So they will get this guaranteed capacity. There is also one option which is available for use cases which doesn't require real-time inference. For example, offline documents processing, or maybe some sentiment summarization from the documents. So if you have some maybe support cases and you need to find the sentiments, you need to categorize them, and you don't need to run it online, like interactive with the user, you can use batch inference. With batch inference, you need to use it like a different API, which is called create model invocation job. And in that API, you provide submit a JSON file with prompts located on S3 bucket, and Bedrock processes them offline and then will write you responses back to S3. And Bedrock processes them within 24 hours since the job is submitted. There is an API to track the job progress, and the benefits of batch inference that it provides you basically 50% lower price than on-demand equivalent, right? So if you don't have requirements for real-time inference, I really want to recommend you to have a look at batch inference. That's a good way to significantly reduce your AI spend. All right, so now we selected a model. We selected a pricing option or capacity option for our models. And let's talk about some cost optimization techniques. So how we can actually run our workloads effectively. And there are a few things which you can use with Bedrock to actually optimize your workloads or run them in the most effective and efficient way. First, optimization technique, if you want to optimize your Bedrock-related workloads, basically you need to use Bedrock less, or you need to use less tokens. Yes, that's the easiest way to optimize. And in these terms, you can optimize input tokens and you can optimize output tokens. For input tokens optimization, you can apply a technique which is called input preprocessing, right? It's basically it's not a best practice to just send everything that your, for example, users provided as a prompts just straight to LLM. because again, it could be anything there. So what you can do is pre-process those prompts in your application logic and apply some, for example, programmatic or deterministic approach to remove some things like white spaces, maybe strip some boilerplates, like greetings. You don't need to say hi to LLMs. You don't need to say thank you for LLMs. And those all things consume tokens. Then when users say thank you and LLM answers with some, well, yeah, happy to help, this all goes as tokens. You don't really need them. You can truncate, remove them before you send to LLM. You can also reduce your amount of input tokens by using smaller models as a pre-processing step. So you can actually use a smaller models to, for example, reduce the input prompts. If it's like some large document, you can maybe summarize the document, or you can take the main points out of the prompt. So when the prompts becomes larger than, let's say, particular size, which you may determine, you may want to actually use some smaller, cheaper model to reduce it, to keep only things that matter, and then use larger model, more expensive, more capable model to process that prompt. And if you manage things like conversation history, if you have like chat-like applications, again, it very quickly becomes like amount of input tokens stacks up very quickly and grow very quickly because models don't have memory. So every time your user send the prompt to LLM, you need to send the entire conversation history. With every single message, this history grows over time. So you can apply in your application logic several techniques like sliding context window, where you just send recent n turns or n messages to LLM. And then you can also apply a history summarization, where you use smaller model to summarize your history first, and then you send the summary to larger model, which again can significantly reduce input tokens. You can also optimize output tokens. For example, you can put some like system prompts or some basically constraints instructions to in your request for LLMs. You can specify the output types, and for example, CSV could be more efficient than JSON. It will consume less tokens as output. You can provide some instructions and behavior to the models in system prompts, like be concise, don't provide any additional explanation unless explicitly asked for. You can provide some example answers, how to be concise, because LLMs by nature, they like chatty, so they want to provide a larger output, explain everything. So you can limit it in your system prompts and instructions. And there is also a property which is called max tokens in Bedrock Converse and Invoke Model API calls. So that max token property is actually defines your maximum output token. So it sets the ceiling of the output tokens. So you can also use it. And one important thing to note here is that if you have, for example, your average output is 1,000 tokens, but your max tokens is set like to 5,000 tokens. You will be billed by 1,000 tokens, basically the actual output. But for your service quotas consumption, you will be, every request will be considered as 5,000 tokens, basically what's specified in max tokens, because Bedrock allocates the capacity based on max tokens property, regardless of how many outputs tokens you get. So if you hitting some throttling and service quotas for on-demand inference, check the max tokens property. Don't put it way higher than your average output tokens. Try to keep it as closer as possible, because that's also the way how you can improve, reduce amount of throttlings and basically requests which hit the service quotas, right? All right, there are a few more techniques which you can apply to optimize your Bedrock spend. We all know that, again, we mentioned like applications which have some conversations. There are also very common use cases when your users may send some document and then have some chats with the document about some follow-up questions. What about the context of the documents? Have chats with LLM. In this case, you can actually cache those repetitive parts of your prompts, and you don't need to send them all every time through all the layers of LLM and use expensive GPU resources. You can specify in your API calls these cache points properties, and what it would mean that everything which is above the cache point will be cached. So on the first API call, Bedrock will actually cache it and will put in kind of internal Bedrock managed vector store. So it will like generate these key value pairs and will put them in vector store. And then on the next requests, it will extract from the cache. It won't be sending and pre-processing entire document in through all the LLM layers. So it will get your kind of portions or parts of the prompts from the cache already. And the cache writes are 10% more expensive than input tokens, but cache reads are 90% cheaper. So if you use caching effectively, you can save up to 90% of costs of your input tokens. So it's very, very powerful and very important. And you don't need to manage any kind of vector stores. You don't need to provision any infrastructure. It's really as easy as specifying some properties in your API calls, like cache points, and that's it. This would be an instruction for Bedrock to start caching. By default, cache TTL is 5 minutes. So basically, Bedrock will keep your records in the cache for 5 minutes. And then if you want to extend it, some models support TTL of 1 hour. So you can basically have up to 1 hour cache TTL. And again, it's very easy to use. And that's the reason why I'm actually showing you the API examples from API calls, because you don't really need to build infrastructure to start using prompt caching. It's natively supported by Bedrock. All right, and the last optimization technique which I want to cover today is called intelligent prompt routing. So we talked also several times about the use cases where you have like some needs to process requests through less capable, cheaper models, which, for example, for tasks which don't require like reasoning or these advanced capabilities. So intelligent prompt routing is a kind of similar technique where you pick a pair of models. One is less capable and obviously cheaper, and one is more capable. And then you route your request depending on the request complexity to respective model. And Bedrock has this as a built-in capability, right? So Bedrock can evaluate your prompts and requests and automatically decide to which model this request should be routed. And to do that, to implement it, the only thing which you need to do in Bedrock is you need to create a so-called router in the Bedrock. And it's, again, very simple configuration. You can configure there your quality threshold, like a percentage. And once you created a router, you can specify router ARN as model ID. Again, very minimal changes on your application sides. And Bedrock will start routing those requests and evaluating the prompts and routing those requests through the router. And if you want to see which model responded to which request in the API response, there is a property invoke model ID. So you can track it either in API response directly, or you can track it via other methods and options, which we are going to cover now. All right, so that's all the kind of main and the most common optimization techniques. And as you saw, all of them are pretty much managed in the API's property or your API payload. So that's very easy to start using them. And again, I would consider you to kind of build your optimization and efficiency strategy before you actually start, large scale adoption of your application. So think about optimization like at the beginning of design phase rather than building everything without caching, without prompt routing, with the largest, like a more capable model, and then thinking how to optimize it. Because the main difference of optimization of AI workloads compared to traditional like EC2 right sizing, that when you change the models, the quality of answers will be different, right? So it will be different. It may be like, it's just a question how much it will be different. So all these kind of changes later require quite significant testing and evaluation. So think about those evaluations from the beginning, how you approach the testing the models, changing the models in Bedrock. There are also native capabilities to run some prompt evaluations. You can use a playground to compare the answers from different models for the same prompt, check how many input-output tokens they generate. There are prompt optimization features in Bedrock as well, so I really want to encourage you to start using them. All right, now we have everything. We started to run our workloads on Bedrock. Now the next question is how we can monitor what actually we're running, how many tokens we get. So how to monitor cost and usage, and how to get like proper observability. There are a few tools available to monitor Bedrock cost and usage. And first tool which I want to cover is CloudWatch. Obviously, you're probably all familiar with CloudWatch. And for Bedrock, there is very wide variety of metrics available in CloudWatch. Things like, for example, tokens count, requests, latency, then throttling if you're hitting service quotas as well. So it's very important to monitor throttling. Then like which models were basically hit, the cache hits, right, as well. You can monitor that metric as well and see how effectively you are using your prompt caching. So all these metrics available in CloudWatch, you can start using them. You can create in CloudWatch like nice dashboard, like your Bedrock monitoring, AI monitoring dashboard, where you can combine several metrics on one screen. Bedrock also allows you to enable prompt logging, so you can log up like every single prompt and have them securely stored and available only for you in CloudWatch logs. So again, you can see in CloudWatch logs pretty much detailed breakdown up to each prompt logged in the CloudWatch. It's very nice service and it's very good for like this operational monitoring. However, it doesn't have any cost details, right? So you have only these metrics, only usage, consumption, cache hits, and things like that. So it also quite challenging to consolidate your all CloudWatch spend for like large organization in one single place. So CloudWatch usually like distributed, right? So you can do that, but again, more commonly than customers like use it per application, per workload. So if you want to see a larger picture or you want to see cost, you need to look for other tools. Obviously, cost data for Bedrock is available in Cost Explorer, the same as for other services. The only few caveats here that Bedrock's cost for third-party models, like Anthropic, for example, is charged and billed as marketplace spend. That's very important to know. And you can see if you apply some filters in your Cost Explorer, all the services which have Bedrock edition in brackets, it means that they build through marketplace, right? So that's why it's important, because if you're using cost anomaly detection in Cost Explorer, which I hope everyone is using, there is important nuance that cost anomaly detection doesn't support marketplace spend, right? So it means that if you run models like Anthropic Claude and you have anomaly detection, they build through marketplace, so anomaly detection won't cover them, right? So make sure that your cost anomaly detection strategy takes this into account. And yes, this is a gap in kind of cost anomaly detection service. I just want you to know about this and be prepared for this. And obviously on our side, service teams working on making it supported, right? But until it is supported, you can set either spending budgets or use anomaly detection feature in CloudWatch. So be prepared for this. Cost Explorer is a good service. However, again, it has cost data. It doesn't have usage data, right? So it's there is another aspect of it. So to get both cost and usage, you can use cost and usage report, right? Which provides you raw billing data delivered to your S3 bucket where you have cost and usage all together. And you can also visualize your cost and usage report data with Cloud Intelligence dashboards, which basically AWS solution available in Solutions Library. And it's a collection of dashboards in Amazon QuickSight, or now Amazon Quick, which every customer can deploy with CloudFormation templates, which we provide in a matter of like 25, 30 minutes, and pretty much get this collection of FinOps and beyond FinOps dashboards, which pre-built by AWS experts and SMEs. and allow you to visualize your spend, consolidate multiple payer accounts or multiple AWS organizations in a single place. We also have dashboards for multi-cloud, so you can bring your data from other cloud providers and AWS in one single place. And the data is stored in your S3 buckets, or if you implement it for your customers, then in your customers' S3 buckets, so it's very secure. Data doesn't need to leave your organization. You don't need to share it with any third parties. And this solution is open source and customizable. So we give you like a framework with collection of ready-to-be-used visuals and dashboards, which you can change. You can edit any part. You can bring your own data to these dashboards, like your business metrics, get into unit economics as well with it. And we don't charge for the dashboards themselves. You pay only for the use of the underlying services like QuickSight, S3, Athena, and usually for typical like average customer, this cost of running this solution is not more than $100 per month. So why I'm mentioning cloud intelligence dashboards? Because in one of our dashboards, which is called Kudos, we have a set of visuals for very advanced and visibility for Amazon Bedrock, where we go to details of spend per different categorization, where we provide your ability to see your spend per tags and see and build like very granular cost allocation. We also calculate things for you like cost per million tokens in many different dimensions as well, which allows to kind of track your efficiency over time and see how your average cost per million tokens changes over time. And we also categorize the Bedrock spend in a very easy to understand way. So let me show you very quickly how it looks like. So here we are. I have a Kudos dashboard, which is basically available with some demo data. And this URL is our public demo, so you can actually play with it later as well. You can open it and check it out. And it uses some synthetic data. And on AI/ML tab in Kudos dashboard, we have this section for Amazon Bedrock, where you can see your Bedrock spend. Again, everything consolidated together, your marketplace spend, your maybe multi-payer, multi-organizational spend all together in one single place with Bedrock and Agent Core, everything all together. And you can see your spend per different dimensions. For example, per account, if you can switch to other dimensions, like if you want to see your spend per model, here we are. Or you can see your spend per usage type group, which is like high-level categorization, which we have in the dashboard, which allows you to actually see what you're paying for in Bedrock, like how much you're using cache reads, cache writes, input tokens, output tokens. So basically all this in very easy to understand terms. You can also see here this cost per 1 million tokens, which is quite interesting because it allows you to see how kind of, I call them like directional metrics, right? So by seeing how it changes over time, you can get some conclusions over your efficiency over time. So in this case, we could see that cost per million tokens went down in June for like our Bedrock spend, and we can clearly see like that we started to use more cache reads, right, which 90% cheaper than input tokens. So that's, I think, the main cost driver here, which actually helped us to reduce this. And in April, for example, we had way less cache reads, and our cost efficiency basically reduced, so the cost per million tokens went up. You can also bring your tags here. You can tag your Bedrock usage, and you can see your tags on the dashboard or in cost and usage report as well. And you can bring different tags here. For example, I have example with tag environment. And I can see now my Bedrock spend per like environments, or you can have like spend per application, or maybe per tenant, or per business unit. And you can interactively select any of the environments. If I want to drill down into my Bedrock spend for staging, I can just click on it, and then rest of the visuals below will be filtered based on my selection. So now I can see how my spend looks like for a staging environment, which pricing models I'm using, like mostly on demand, right? And no batch inference and stuff like that. No flex, which maybe we should use for staging or maybe test and stuff like that. Then you can also see some metrics like which models we are using and what's the cost per million tokens within all those models. What's our average cost per million tokens within this application? And and break down up to inference profiles IDs which are used and in which regions those inference profiles are used, and also like amount of tokens. So not just cost, but up to millions tokens details. Yeah, you can see here. Another very interesting insights you can get and kind of to reason about your effectiveness is cost per million tokens per model. Because even within one model, as you can see here for like Opus 4.6, we can see that cost per million tokens for our usage within that model went up. So you can click on that model to dive deep and investigate what went wrong. And now everything is filtered for based on that for only for that model ID for Opus 4.6. Yeah, and in this case, what we can see that in June, when our cost per million tokens went up, what we can see that we actually, for this model, we started to use way less cache reads, right? So we can even dive more deep and look, we can select the cache reads, and now we could see which environments or which applications maybe, so whatever tags you bring here, have less cache reads in June. And we could see the most significant one was testing environments and also staging environment well done. So basically, and like sandbox went up for some reason. So in a matter of few clicks, we managed to kind of assess a little bit our efficiency within like particular model, and we could see which taxonomy dimensions actually impact it. So it very quickly allows you to get some understanding how well you're managing all these optimization opportunities and how your efficiency changes over time. And you can deploy this dashboard from AWS Solutions Library. We provide CloudFormation templates to do that. Let me switch back to the presentation because you saw that I used tags to allocate my Bedrock spend, and I want to cover in a few minutes how you can tag your Bedrock usage, because Bedrock usage is API based, right? So you don't provision any resources like with EC2 or EBS. So in Bedrock, you cannot actually tag respective API calls with cost allocation tags. However, you can tag several things. First, you can tag inference profiles. So what we talked about cross-region inference, like global, geographical, cross-region inference. So you can tag inference profiles and so with cost allocation tags, and then bring those tags to the dashboards, to Cost Explorer, if you enable them as cost allocation tags. It was available since quite a while, and we heard from customers that it's not flexible enough, because if you want to tag your Bedrock spend per application, per tenant, you don't want to create like thousands of inference profiles. So very recently, we launched a ability to tag your Bedrock spend by IAM principles. What does it mean? So now you can tag IAM roles, which make under which you make Bedrock API calls, and those tags from IAM roles will be propagated as a cost allocation tags to Cost and Usage Report and Cost Explorer. Now you may say, I'm using one shared role across multiple tenants or across multiple applications. Can I go even more flexible? Yes, you can. You can also tag your IAM sessions. When you run assume role, and you can send those session tags like team user in this example, and those tags will be then propagated as a cost allocation tags for any session which made with these credentials, which basically assumed with the session tags. So this is very powerful and provides you a lot of flexibility. And the beauty here is that you don't really need to change much in your application logic. So your Bedrock converse or invoke model APIs stay exactly the same. What is slightly changes is you need to send your tags into assume role API calls, or you need to tag your IAM roles. Another thing which appeared to help you with cost allocation is in CUR 2.0, there is a new column which is called line item IAM principle. So even if you are not using tags, you will see which IAM role is used to make API calls in this column. And if you are using things like Claude via Bedrock, you will see the IAM role, which is basically used then in permission sets in Identity Center. And as a session, and then with a role, you will also have as a session name, which will be a username who uses the Bedrock through Claude. So you will get in this column your Bedrock role and username, for example, for the use cases of using Claude with Bedrock. So this is very, very important because it's a new feature and it provides you a way how you can allocate Bedrock spend and then see this breakdown by environment, application, basically the business purpose of that spend. And it enables you to actually then reason about was the spend worth it, right? Because that's the main question which we need to ask ourselves, right? What's the return of investment of our AI workloads? All right, let me conclude. So, and I want to finish this presentation to also mention one important topic. So what we just discussed, like how to run workloads, how to optimize them, how to track them, it's all important, but what is even more important, more important to have, like to approach it from systematically, to build your governance framework or build your governance principles for AI workloads. And if you look at those principles, it's pretty much the same as for any other workloads which you run on AWS. So it's a least privileges principle, right? Control access to the models, enable only models which you approve to use in your organization, basically control access who can do what. Then implement all these cost monitoring dashboards, tools, CloudWatch dashboards and metrics. Make sure that you monitor your spend. Set the budgets, right? Put some boundaries on your spend. Make sure that you stay on top of it. Make sure that you have anomaly detection in place. This is very important. Again, Bedrock is charged per API calls. These costs can surge very quickly, so they can go up depending on the usage. And actually, if you're using like agents with Bedrock, so agents can quickly consume a lot of tokens because they need to reason, they run those agentic loops in the harnesses. And basically, having cost anomaly detection in place, it's important. Bear in mind this marketplace gap, so make sure that you prepared for it and it doesn't come as a surprise to you. Establish cost allocation strategy. Again, nothing new. We need to allocate costs by different business or taxonomy dimensions. So Bedrock allows you to allocate the cost by IAM principle. So use this to make sure that you actually understand which applications, which tenants drive your costs and how to optimize them. And of course, one of the most important things is to make sure that you can answer the question, does this AI spend actually worth it? Do you define your KPIs to measure return of investments? And here you can do several things. One is to track cost efficiency. Like we have what I showed on the dashboards is like cost per million tokens, which is like, it's not perfect metric. I do understand it. And we mentioned that the tokens are different per model, right? But it's nice directional metric. So if you look at this metric over time, it kind of shows you directionally where you're heading to. Are you more optimized or less optimized? And then, of course, the holy grail of cost efficiency tracking, it's getting into unit cost economy. Being able to track cost per business driver, like cost per customer, cost per API call, cost per response, cost per task, right? If you have some agentic workloads. So, and to do that, if you use, for example, Cloud Intelligence dashboards and Kudos, and you already have your cost data in the dashboards, you can bring your business metrics there as well and join your cost data with your business data and to calculate those cost per business drivers. So it becomes very, very easily. So you kind of halfway there. And then, of course, measure return of investment. So make sure that you have ways how to measure the impact of your AI applications, like improvement of customer satisfaction score, maybe reduction in support cases, reduction of time saved, the time spent per employee for particular tasks, or maybe some conversion uplift. So basically, whatever the main purpose of your AI workload, so make sure that you're able to track the impact and efficiency. And because that's what I see among the industry trends, that's the main kind of challenge which organizations face today is basically justify that AI spend and make sure that they understand the business value which it drives. So make sure that you approach it and on early stages, like more early you approach it, the better. So like bear in mind all these key governance principles. With that, I really like to thank you for joining us today. And if you want to stay connected, here is my LinkedIn profile. So feel free to connect with me. And if you have some questions about optimization of AI services and even more, feel free to drop me a message. I'm very passionate about it and always happy to chat with you.